Today we're writing proportions. So one way to write proportions is to use a table. So you take the data and you organize it in a table. So here I'm comparing my cell phone bills, the ringtones I purchased last month and how much it cost compared to this month. So last month I purchased 2 ringtones and it cost me an extra $6 on my bill. This month so far, I have purchased 3 ringtones. I'm trying to figure out how much that's going to cost me extra on my bill. So what I can do when I set up all of my data in a table is use the columns or the rows to set up a proportion that I can then solve. So if I use the columns are going down. I would compare the 2 ringtones last month to their cost, $6, set that up as a ratio. And my second ratio is going to be this month, 3 ringtones to X dollars. I'm going to set them up equal to each other, and I can use this proportion to solve for X. I can also use the rows to set up a proportion. So rows go horizontally. So I can write a ratio comparing my ringtones. I had 2 ringtones last month and 3 ringtones this month. And I can write a second ratio comparing the dollar amounts. $6 over X dollars. I can solve either of these to find the value of X. So let's look at setting up some more ratios. Here we have a chef who has increased the amount of ingredients in a recipe to make a proportional recipe. The new recipe will have 6 cups of black beans. That's all they're telling us about the new recipe. But here is the recipe card, so I know what was in the original recipe. They wanted us first to write a proportion that gives the number of tomatoes that we'll need to use in the new recipe. So I set up a little table here. So I already knew the black beans compared to the old recipe and the new recipe was 1.5 cups in the original recipe. I found that from the recipe card. And the chef told me that there's going to be 6 cups of black beans in the new recipe. For the tomatoes, I only know the original recipe had 1 tomato. So X tomatoes is what is in the new recipe. So I can set up 2 different proportions. I can either do a proportion using my columns, so I can compare 1.5 to 1 and 6 to X and use that to solve for X, or I can use my rows and compare the amounts of black beans, 1.5 to 6, and tomatoes, 1 to X. I can use either of these proportions to solve for the number of tomatoes that I'm going to use in the new recipe. Let's try to set up a proportion that gives us the amount of water we're going to use in the new recipe. So once again, the only thing that was given to us was black beans. Black beans is 1.5 cups in the original and 6 cups in the new. I know water was 2 cups in the original from the recipe card, but Y cups in the new recipe. So I can set up my proportion using the columns. So 1.5 cups compared to 2 cups, and these are both from the original recipe. In the new recipe, I'm using 6 cups of black beans and Y cups of water. So this is one way that I can set up my proportion and solve for Y. Another way that I can set it up is to use my rows. So 1.5 cups of black beans compared to 6 cups. And then I can compare the water, 2 cups to Y cups. So both of these proportions, can be used to solve for the value of Y. Now there's different ways to actually solve proportions, but we're going to start today by using mental math to solve our proportions. Some of them, including the ones that we're doing today, are going to be easy enough that we can solve them in our head. So when you're using mental math to solve a proportion, such as 3 over X equals X over 8, the first thing that you want to do is stop and think about the problem. So here my denominators are completed. I go from 2 to 8. So I'm thinking about how did they get from 2 to 8? 2 times what gave them that 8? I think, oh, it's 4. Once I know what that is, I go back to my incomplete numerators. I get from 3 to x, and I think, well, they did that by multiplying by 4 down here, so I'm going to do 3 times 4 here, and my missing value here is 12. I can do all of that in my head. So let's try that with some of our problems over here. So first I find the completed one, 5 to 20. To get from 5 to 20, I'm multiplying by 4. So I have to do the same thing on the bottom. 8 times 4 gives me 32. So the value of D is 32. On this one, my completed one is up here on top. 7 to 14. 7 times 2 will give me 14. Now here I have a Z and I end up with 10. So it was times 2. So what times 2 gives me 10? Z has to be a value of 5. 5 times 2 would get us to 10. On this one, I would actually have to divide or multiply by a fraction. 24 divided by 3 gives me 8, or 24 times 1/3 gives me 8. So if I'm thinking 21 divided by 3 or 21 times 1/3 is going to give me x, I get for x the value 7. So let's try to solve a word problem. Here it says a school has 950 students. The ratio of female students to all students is 48 to 95. Write and solve a proportion to find the number of F students who are female. All right, so we know that the number of females is the ratio 48 females to 95 in all, or 95 total. And in this school, the total is the one given to us. It's 950. And they're wanting to know if it was increased to 950, how many females would we have in this school? We're going to call this F. F females. So we're going to do this mentally. So here is my completed one here, 95 to 950. So to get from 95 to 950, I'm multiplying by 10. So up here I'm going to do the same thing, 48 times 10. The value F stands for 480 female students.